Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In this video, I want to discuss about pumping lemma for context-free language. What is the use of a pumping lemma? If you take a language L which is not a context-free language, then it will say that it is not a context-free language. So what I want to say is it is useful for as a negativity text. It will never useful as a positivity text. Meaning is that if you take a language L which is already a context-free language, then pumping lemma will not say that it is a context-free. But it will say if you take a language L which is not a context-free language, then it will say that, or we can prove that it is not a context-free language. Already I have discussed pumping lemma for regular language. Those who have watched that video or those who know pumping lemma for regular language, this video is quite easy for them because both the statements and proofs almost identical. Let me discuss about the pumping lemma for context-free language. If A is a context-free language, then A has a pumping length P such that any string S where length of S is greater than or equal to P may be divided into 5 parts. Okay, the string S we have divided into 5 parts consists of U, V, X, Y, Z such that the following conditions must be true. What are the conditions is we have 3 conditions. What is the first condition? U, V power I, X, Y power I, Z must belongs to the given language A for every I greater than 0. And the second condition is the length of V and Y should be greater than 0. The length of V, X, Y should be less than or equal to P. Is it clear? Are you able to understand? So, if you take any string which should satisfy these conditions, if it is satisfying, then I will say that it is a context-free language. Otherwise, we can say that it is not a context-free language. Let me take an example and we will discuss with a proof. Okay, this is the statement. Let me discuss the proof for it. Then we will go for an example. Now, how I will prove is that I will prove it in a contradictory way. Meaning is that first I will assume that A is a context-free language. Because what is the use of this one? It will prove that a context-free not a context-free language as a not a context-free language. Means if you take a language L which is not context-free language, will prove it as not a context-free language. Now what I will do is that I will consider that A is a context-free language. Okay, I will assume that A is a context-free language. If I assume the context-free language, it should satisfy this condition. So what I will do is that I will take a pumping length P, okay, such a way that the string, any string if I consider from that one, it should be less than or equal to P. Are you able to understand? So for that language, I will take a pumping length P. Is it clear? Are you able to understand? Such that if you take any string where S belongs to, the length of the S should be greater than or equal to P. So, if I take pumping length P is equal to 3, let's take that I have taken pumping length is P is equal to 3, then S value should be greater than or equal to 3. So, for safety we can take that S value is also equal to 3. Okay, just for to avoid the confusion, or you can take that S value as 4, 5, anything. But you should divide that S into 5 parts. So U, V, X, Y, Z. So we will also divide the string into U, V, X, Y, Z. We can divide into multiple ways. All those ways we can discuss. Such that the following conditions must be true. Now once you divided, you have to take a I value such a way that U, V, X, Y, Z, it should be I value should be greater than 0. Your I value should be greater than 0 and you have to divide this S into U, V, X, Y, Z. You have to divide into any number of ways how it is possible. Is it clear? Are you able to understand? For a regular language, we divide into 3 ways. Is it clear? So similarly, we can divide into multiple ways. For all the ways or all the cases, you have to prove that these three conditions are not true. If it is not true, then what I can say, it is not a context free language. Then I can say that whatever the assumption I have taken is a wrong assumption. Let me discuss again. You take a string which is length is greater than or equal to p. You divide that string into u, v, x, y, z. Okay, you can divide into various number of cases or scenarios. And each scenario, you should prove that these conditions are not satisfied. If these conditions are not satisfied, what is the meaning? When these conditions will be true, if A is a context free language. If my conditions are not true, then what I can say? The given statement or whatever my assumption is wrong. So I can say that A is not a context free language. So I hope you have understood what is the statement and what is the proof or what is the procedure to go for a context free language pumping lemma theorem. Okay, I hope it is clear. If you does not understand the statement and the proof, don't worry. I will take an example and I will discuss so that whatever the doubts you have, it will be cleared in the next video. Thank you for watching my video. Have a nice day.